Yo, welcome back to the channel. It's your boy Street Coder Nate, and in this series, we talking about asynchronous programming. In previous video, we just talked about callbacks and how we could pass functions into other functions and then call those functions inside. We saw different ways of doing it, but the JavaScript way is the callback way. And so it was very basic though. Today, we're going to show you why you need callbacks in JavaScript. So let's tap in with that. Here's the lesson: asynchronous programming, right? Asynchronous JavaScript. So what is asynchronous JavaScript? We've been throwing this word around a lot, man. If you ever just want to impress somebody, just say async. Low key be like, oh yeah, I know how to develop asynchronous code, and then be like, oh, you dope. Okay, here we go. So asynchronous JavaScript. So I will finish later is basically the purpose of asynchronicity. Functions running in parallel with other functions are called asynchronous. A good example is JavaScript timeout or set timeout. We're going to talk about set timeout here, but typically in a file, let me see, or I actually had this from the last lesson. Typically, what is referring to is basically right here the execution of function 1 and function 2. So how the program is typically going to run function 1 versus function 2 is that function 2 is going to run first, and when function 2 finishes, then function 1 will run. Well, let's slide back over here, and it says that functions running in parallel with other functions are called asynchronous. So running in parallel means to, well, if anything's parallel, they're like this. And to be running in parallel means they're running together. They're not running one after the other. That's called synchronous. Run after the other. That's normal operations. When we run function 1 or function 2 first, and then we run function 1 right after, that's called synchronous programming, and that's pretty much normal. You don't really put much thought into that, right? Well, asynchronous programming is saying, what if function 1 and function 2 was running at the same damn time on some future shit, right? So that's pretty much what asynchronous programming allows us to do. It allows us to run multiple operations at once. And if you think like a human, like we don't just do one thing after the other. We pause on certain things, we come back to it, then we start the operation up again. Let's say I was making some food, there's no way I'm about to stay in the kitchen for 20 minutes while this bakes when I could be using that 20 minutes to do something else. So while I'm baking, that's an operation, right? While I'm baking, I'm about to go do something else. I'm about to probably go read a book, watch TV, work out, something. And then after I come back, you hear what I said? And then after I come back, after the what is it called? After the, let's call it some bread gets done baking in the oven, then I'm about to go open up the oven, or then I'm about to stop the operation that I was doing, let's say working out, and then go to the oven to take the bread out and tender to it. Pretty much JavaScript. It's like I got this operation going on. It may take me a little too long. So you know what? While this operation processing and whatnot, I need you to go run off and do some more operations. Don't just sit here and waste time, waste materials, waste all this whatever, while you could be using that time and materials for something else. That's what asynchronous programming is. And if you think about it, how humans think and how humans operate, that's really what it is. We just don't do things synchronously typically. Now there are things that we have to do synchronously, like step by step, but then there are other things that we can do in parallel that will help us execute things a lot faster. And so that's just what JavaScript is doing, is just bringing that into computer science. So the example used in the previous chapter was very simplified. The purpose of the examples was to demonstrate the syntax of callbacks, right? And so we already talked about callbacks right here and how you pass in a variable, an identifier to the function. You don't pass in the function call, you pass in the identifier to the function, and then you let the function that's taking that you pass it to take care of it with my callback parameter right there. So in example above, my displayer is the name of the function. It is passed to my calculator as an argument. In the real world, callbacks are most often used with asynchronous functions. A typical example is JavaScript set timeout. Okay, so these examples up here, basic as hell, like hella basic. And these examples are actually just synchronous code, but they tried to show you callbacks using synchronous code. And I know y'all probably like, I could just do this the other way. Well, now I'm about to show you the importance of a callback with asynchronous code. You typically wouldn't use it with some synchronous code. It just make things way more complicated if you did, for real, for real. So, all right. So the way that we do it is, or an example of a callback is the set timeout. So let's take a look at it. When using the JavaScript function set timeout, you can specify a callback function to be executed on timeout. So what does this mean? Set timeout, my function 3000. We define my function down here, so obviously my function right here is the reference to the function. Oh my bad. The function right here, defined right here. So what does set timeout do? Well, set timeout takes in a function right there, a function reference, and then it also takes in the time that it's going to take to pause. So, or it's going to take the time that we want to set the timeout for. And a timeout is just kind of like a pause, right? So basically this is going to say pause for, and this is in milliseconds. So it's going to say pause for 3 seconds. And after 3 seconds, I need you to run my function. Now, it's going to pause, but if there was something else to do, like if we had another function right under set timeout, it would run that function and then run the 3000. I hate talking like that, so I'm just gonna copy this over to Visual Studio Code and go like these. Okay, refresh the page. Bet. So we got the set timeout right here, and we get a type error down there that says null is not an object document. Oh, I got you. Yeah, here we go. We don't have a document right now. So what we're gonna do is just simply say return I love you. And you should see I love you print out after 3 seconds. Let's see. It didn't. Oh wait, my bad. Not return. We won't print or console.log. Thought I was in Python for a second. All right, cool. So what y'all gonna see is after 3 seconds, bam, I love you gets printed out. So we got the file loaded, and then we set a timeout for 3 seconds, and then after that timeout expired, my function right here was ran. Y'all see, after the 3 seconds, my function was ran. And what is my function? My function is defined right there. Now, this is important because what if I do console.log, yo, this is ran before my func. Right. So what do y'all expect to happen right here? Like, so we got set timeout, my func. Like, if we gonna time out for three seconds, do you think we're gonna print out the yo after the 3 seconds or before the 3 seconds? Let's find out. Bang, well, we got our file right here, my file, then we got yo. This is, let me go ahead and move myself over so y'all can see where I'm pointing at. And then we got this, we got file loaded, right? Actually, let me clear this for y'all right up here. I'm about to clear it over there. We got right there, and refreshing the page using Command R. You see right now, you just got file loaded, and then yo, this is ran before my func, and then you see I love you. I love you comes from my function. So what in the world just happened here? Well, set timeout is a function and it's running, right? Set timeout is a function that's running, and it's running because it needs to know that 3 seconds has passed. So it's counting the seconds. That's what my function, or that's what set timeout is doing. It's counting the seconds. It's pausing. Honestly, it's just it's a function that counts seconds in my eyes. And so here it's going to count 3 seconds, and after it finished counting 3 seconds, then it's going to run my function. Well, just because it's counting 3 seconds, that's a long operation. What if it was counting 10 seconds? We don't want the program to sit there and wait for you to count 10 seconds. So what we're going to do is continue running. We're going to continue running. Set timeout now ran in parallel with the rest of the file. So this console.log ran synchronously, right? All programs naturally run synchronously, meaning they run from the top where you say line 1 at to the bottom, and they're going to call things, and they're going to execute functions that are called. They're going to save functions that are defined and execute functions that are called. And so here, this is a function console.log, so it's going to call that function first, which you see down there in the terminal. I hate this. What you see down there in the terminal, turn the finger. Okay, what you see down there in the terminal where it says file loaded. Now, if we come back up here, we see the set timeout. That's another function call. And so we're gonna call that function, but that function is gonna take 3 seconds. 3 seconds is a long ass time in computers. So it's gonna take 3 seconds, but after it takes 3 seconds, I need you to call my func. Okay, so do we pause for those 3 seconds or do we continue executing? Well, we continue executing. So we fire off set timeout, and set timeout now is executing, but then we say, oh, we're set timeout is an asynchronous function, so we can continue executing executing the rest of the program while set timeout is executing right now. So like the rest of the program is going to execute and set timeout is executing at the same time. Like set timeout didn't finish. Like typically, like console.log had to finish before set timeout could get ran. Now that set timeout gets hit and ran and says you don't have to stop and wait for me, then line 4 can happen. Line 4 is happening at the same exact time as the set timeout is counting those 3 seconds. And so line 4 only takes a second to not even a second, less than a second to really execute. So therefore, it's going to be printed out. Therefore, it's going to be printed out before I love you, which was defined right here in the my function, right? So after those 3 seconds finish, then we're like, all right, print out I love you. So set timeout was running in parallel with the console.log. Get that right. It was running in parallel with the console.log and the rest of the file. Now my function is the callback to the set timeout, right? So the set timeout was what was doing the asynchronous operation, running with something else, and then after it finished its asynchronous operation, it called back to a function that it needed to run after its asynchronous operation was done. That's kind of dope. Right now, we're just using set timeout, but there are other things that take time, like loading files from a web server, loading files from your own computer, breaking things down into JSON, like that, stuff like that, converting stuff, it takes time. And so because it takes time, we don't want our CPU to be blocked. Blocked meaning it can't do anything else. It can't process information for other programs or this program. Basically, it just has to wait until this operation is done. And imagine if you was doing in your program, like they click the like button and you had to wait until that you get a response from the web server that the like button was clicked. Like everything on your computer paused until we sent the response, or we sent the request to the server saying, yo, Nate just clicked the like button on somebody's picture, and the server saying, all right, I'm gonna save that information in the database, and then sending back that message saying, yo, it just got saved in the database, turn the thing green or blue, turn the thumbs up blue. Well, now it's like that operation took some time, and in the synchronous world, the rest of the program would just pause until that operation finished. The rest of the program paused. Now imagine you on Facebook, every single time you like something, Facebook just froze until like the response came back from the Facebook server. That would be hell. So what happens is when you click that like button, that request gets shot off, and that request is technically still running, still waiting, but now, because it's still running and still waiting, the CPU can use its resources to do something else rather than wait on this response to come back. We can continue scrolling through the page, continue loading pictures, continue all of this. But if it was synchronous, we weren't able to do that. And this pretty much is the point of asynchronicity. Honestly, I pretty much explained it without W3 schools, but let's see if I missed anything here. So when you pass a function as an argument, remember not to pass it with parentheses. And I told y'all that in the callback as well, in the callback lesson as well, that when we pass this function right here to set timeout, it's my func. It is a function reference. It is not an actual function call. What do I mean by that? Well, to call a function, you put the parentheses at the end of it. We don't want to pass it like this, because what this does is automatically runs my func. What we want to do is pass a reference to my function, right? We pass the reference to my function, and now there we go. So we pass the reference to my function, and after 3 seconds, we're going to take the reference, we're going to follow the reference to where the function is, and then run that function. That's what the important part of all of this is. And that's what set timeout does. Cool. Now, set timeout can take in, like I said, a function reference, right? A function reference is just where that function lives in memory. But it could also take in an anonymous function. An anonymous function doesn't have a name pointing to it. It's just a function like this. This is technically a function reference, but there's nothing referencing that function. So we call it a function literal, or an anonymous function, right? And so in this anonymous function isn't ran. Like passing, this is honestly us defining a function right here. We're defining a function in line, and in this function, we could call my function like this. So this is getting real JavaScripty, but the first parameter is an arrow function, and an arrow function is a function reference, meaning that it's not going to be ran until something runs it. So what do I want the operations to do inside of this function? Well, the operations is, why don't you just call my function like that? So instead of me passing my function in, now I'm passing in this arrow function that's going to call my function when the arrow function is called on. That's important, because you'll see this syntax a lot more than the actual function reference name being passed. You'll see more so the inline defining of a function right here. And so I just want to make y'all hip on that, because that's what W3 Schools is about to show y'all, is that y'all could pass in an anonymous function right here. And they just use the old school way of writing function. I use arrows, they use old school. If you don't understand functions, go check out some of my videos on functions, but I'm not about to explain them today. So in the example above, function and as you see, it got function, and then it calls my function inside of it like that. Cool, right? And then it calls my function inside of it. In the example above, function is used as a callback. It is a complete function. The complete function is passed to set timeout as an argument, right? So 3000 is the number of milliseconds before timeout, so my function will be called after 3 seconds. Waiting for intervals. When using the JavaScript function set interval, you can specify callback functions to be executed each interval, right? So we just got done doing set timeout, which says like after 5 seconds run this function. Well, set interval says after every 5 seconds run this function. And so we can is pretty much asynchronous again, right? Because now it's, instead of just running 5 seconds or counting 5 seconds and then run a function, it's counting 5 seconds, run a function, count 5 seconds, run a function, while the rest of the program is still continuing doing what it's doing. This is important. Because now you could make a timer, and the timer can update every second while you still doing other things in the foreground of the browser, right? So these like callbacks situation things are real important and real dope. Callbacks in asynchronous code. Okay, we're almost here. Okay, waiting for a file. This is important. If you create a function to load an external resource, that's what I was talking about, an external resource. So is that a file from your computer? Is that a file from a computer somewhere else called a server? Like we want to load resources 9 times out of 10. We either want to load a file or load data 9 times out of 10. And so you cannot use the content before it is used. So if you want to load a file, it takes time. Therefore, you cannot start using the content of that file before the file is loaded, is basically what it's saying. So it says this is a perfect time to use a callback. Just how set timeout took some time, right? It counts the time, it counts the seconds, and then or milliseconds, and then it prints your or then it runs your function. Well, loading files takes time too. It takes time to get all that data from somewhere else into your program. So while that time is happening, the rest of the program is executing. And then after all that data has been loaded, we can call back to an operation to do something with that data. We can't do something with that data until we get it in, but we don't want to wait. We don't want to wait for that data to come. So we call back to it. Now you see the importance of callbacks. So asynchronous operations are going to take a long fucking time to run in terms of computers, right? For us, a 1 second to 2 second process ain't shit. A half a second process ain't nothing, but to a computer, it's a long time. So in order to save time, okay, while you loading that file, I'm gonna go do 2 plus 2, 3 plus 3, console.log some stuff, run a couple if statements, and then it's like, oh, okay, now the file is all loaded, bet. Now I need to do something with that information. I'm going to call back to this operation that I passed into you as a callback. Point of callbacks. Got it? Honestly, we ain't gotta go through all the code for this, and that's not, yeah, we're not about to do that, but definitely check out W3 Schools, walk through this code and see exactly what's happening with the callback. The video already about 20 minutes, but yeah, the callback, cool. And that's pretty much callbacks asynchronous. So, oops, in the last video, there we go. In the last video, we talked about callbacks, and we seen these real basic examples of using callbacks, and it was like, why wouldn't I just use like regular synchronous like operations? But now in this video, we seen that the reason that we need callbacks is that in JavaScript, there are processes that take a long time, and we don't want our CPU to wait on those processes. So we're going to continue to do the things that we can do while those long processes are running. But after those long processes finish, there's typically work to do. And so we need our CPU to come back. So what it does is it calls the CPU to come back to it and finish executing another function called a callback. That's the point of callbacks and asynchronous programming. Now in the next video, we're going to get into promises. This is a way that JavaScript implements asynchronous programming. I'll see you in that video. Peace.